This year, I'm putting C9 RGB Christmas lights on my house that can change to any color pattern I want without having to physically swap light bulbs. The front of my house is pretty simple, so I'm planning to put lights along the gutter and around the gable. I also have a wreath for the gable and lights for the evergreen tree in the garden. And finally, I'll outline the garden with lights on garden stakes. These will all be RGB pixel strings that connect end to end with power and data wires. The beginning of the first string is attached to an LED controller that tells each light what color to be. If I use a controller with one output, like this Atom controller, I'd need to connect all my strings end to end. So it would make the most sense to connect my controller at the beginning of the ground string and send the signal to the right, then up the tree, to the gutter, to the gable, and end with the wreath. The trouble with this approach is that it's so many pixels that I'd need to inject power somewhere in the middle of the line because there's a slight voltage drop from each pixel and foot of wire. The best practice is to inject power every 200 pixels for 12-volt strings, more often if you want to use 5-volt pixels. For me, the better approach is to avoid injecting power by using a controller that has multiple outputs, so I can put it centrally located on the corner of my house. That allows me to use one output to power the lights on the gutter, gable, and wreath, then use a second output to power the lights on the tree and the ground. The Atom controller only has one output, so it's not good enough for this setup. So I purchased a Did You Know controller from Dr. Z's for $34. It has two output channels, plus a 10 amp fuse with different Wi-Fi options. You can see I bought the one with the external Wi-Fi antenna. It has an ESP32 processor that comes pre-installed with WLED, and also has a logic level shifter that provides better signal if your first pixel is far from the controller, which is good for me because my gutter is 10 feet off the ground. It supports 5 to 24 volt LEDs. It also has selectable signal resistors depending upon the type of wire for your strings. 249 ohm is the default, but that assumes that your data and power lines are separate. With my X-Connect cables, the data wire runs right next to the ground wire, which degrades the signal. So I flipped these two little switches to use 33 ohm resistors, which are tuned for my cables. If you have a bigger light installation, they also make a Dig Quad controller with 4 output channels, and recently announced a Dig Octa controller that can have up to 16 output channels. I connected 2 female pigtails to the Did You Know by attaching the yellow data wires to the LED 1 and 2 terminals, and connecting the brown and red wires to the positive terminal, and the black and blue wires to the ground terminal. Although I got both of these pigtails from the same vendor, you can see the wire colors may vary. Next, I connected the 12-volt power supply and was ready to test my lights. Pardon my messy office, but this is where I laid out all the lights to just do a dry run. And so the lights you see across the back there, those are the ones that are going to go on the house. And I've got 3 strings for that. And over here, this string is going to be pixels that are going to go in a wreath. But the trouble is, the wreath is going to be far away from the end of that string. So I have an extension cable here that I'm going to try, and I'll show you what happens. Now with the extension cable plugged in, now that's a 20-foot extension, that you can see it loses signal. It doesn't display, and I didn't touch WLED, so this is the same program, and those things were supposed to all be this color, and they are not. In fact, most of them are out completely. Now the reason for that is that the signal from the end of this string loses enough voltage that it doesn't get over here well enough, and that pixel can't boost the signal well enough for the rest of the string. So it's not a power injection problem, it's actually, it just needs a signal booster. And over here on another channel, I have 3 strings of pixels here. These are going to go on a Christmas tree out front. And then that set of C9 bulbs are going to go along the front of the garden with garden stakes. So if this is where the controller is, I have a 10-foot extension to the bottom of the tree, which is pretty accurate, I would say. And then I'm going to have those 3, and then I'm going to have another extension that takes it over to the next, to the ones in the front of the garden. The problem is, these are fine when they're red, but watch what happens. And even if I change them to blue, they're okay. But if I go to brighter colors, like I'll go to yellow, you see the flickering starts? And if I go to white, you can see it for sure. So that's, again, signal loss because of that extension. So I need to put a signal booster in there. So that's really why it's important to do this kind of testing ahead of time. Before you go to put them on the house, you want to know that everything's going to work the way you expect them to. The solution to this problem is to insert this little signal booster board in the gaps between the strings. I bought these for $5.50 each, also from Dr. Z's store. They not only boost the signal, but they also provide 2 lugs and screws to inject power if necessary. The data booster also has a resistance selector switch, which I set to 33 ohms just like I did on the Digi Uno. I'm putting the signal booster in the middle of a 10-foot X-Connect extension cable, so I cut the cable in half, then strip the wires. I used a soldering iron to tin the ends of the stranded wires so they're easier to insert in the terminals. It's important to be aware of the data signal direction. The male connector with the pins gets connected to the D-in terminal. The female connector goes to the D-out terminal. I connected the female side to the D-out terminal first. The yellow wire is data, black is ground, and red is positive, which is labeled VCC on this board. Then I connected the male side to the D-in terminal. I always give the wires a tug to make sure they're good and tight. Now let's give them another test. All right, so here's that string that's not working. I'm just going to take my cable here with the booster board on it, and I'm going to insert it in the middle. And there you can see, it fixes the problem. They're all purple again. Now let's try the same thing on this side. Here's the booster board cable. I'm just going to plug this one in. Now mind you, this is adding 10 feet to this extension as well. The fact that it works is really an amazing thing. It's even got a nice little, cute little LED on here to show you that it's got power. So there you go, it solves that problem too. To use the signal booster outside, I needed to install it in a waterproof enclosure and use PG9 cable glands to seal the wires. Some people swear by coating electronics in hot glue to make a waterproof cocoon, but I chose to spend $10 on an enclosure to house it. It's a little ridiculous that a plastic enclosure would cost more than the device itself, but it is what it is. The cable glands require a big hole, so I used a 1/2-inch brad point drill bit to very carefully drill a hole in each side of the box. The glands tighten around the cables very well, but I tied the wires in the case because it's an extension cord and I know I'm probably going to pick it up by the wires. The signal booster is very light, so I didn't bother securing it in the box. The top gets attached with 4 plastic screws to create a nice waterproof seal. The control unit needed a much larger box to fit the power supply. I attached the power supply to the base with the included screws, but the screws were too big for the Digi Uno board, so I just attached it using a zip tie. The lid on this box is hinged with stainless steel latches for easy access. You could see why I wanted the external Wi-Fi antenna so it would stick out of the box as far from the power supply as possible to get the best signal. My only concern is heat from the power supply because a weatherproof case is invented, but it's pretty cold in December here in New Jersey, so I don't think it'll be an issue for me. Back in the office for a final test, you can see all the lights are working perfectly, even the signal booster with 30 feet of extension cord between the strings. Now I'm all ready for installation, but that'll be a separate video. If you need shade on your deck or patio this summer, check out Toya Grid Pergola Kits. You source the lumber locally and can assemble this modular system in as little as 30 minutes. Check the video description for links to videos and more information about Toya Grid.